Good morning, fellow programmers. Thanks for joining me. I'm T-Pain. And welcome to Let's Learn C++. Feel free to use the skip ahead feature in the right hand side to jump to any specific sections or examples. Make sure to have annotations turned on so you can see what updates I make to these videos. I'll be using Visual Studio Community Edition 2015, I believe, which you can download from visualstudio.com. However, you can follow along with whichever software, IDE, or text editor you like. Today's focus is pointers and references, which builds heavily on previous lessons, so check those out if you're unfamiliar with a topic. If this is your first programming language, I'd strongly recommend checking out my Let's Learn Python series, which teaches you the fundamentals of programming. All you need is the Basics and Object-Oriented Programming series, linked to the right, and you'll be well prepared for this C++ series. Alright, so what is a reference? When a friend quotes a terrible movie, he is making a reference. Because it is a terrible movie, you are no longer friends as well. Friends don't reference terrible movies, ever. Unless you're me. Then you have no friends to reference terrible movies with. Okay, but what do references mean in C++? All this time we've been creating variables in Python and C++. There's actually been several parts to making and creating a variable. First is the variable identifier, or the name. Second is the data type and size. Third is the actual data being stored in memory. And lastly, and this is the most important, is the place in memory where it is being stored. When you create a variable, it stores the data in memory in a certain location, called a memory address. This address is pretty much a random string of characters, in hexadecimal form, I believe. Every address is unique, but sequential. So if you were to print out the addresses before and after a given address, then you'd see that they were, in fact, in an order. So the variables that you create are stored at a unique address. Now I want you to think of data being stored as a rectangle and the address as a hoop or ring attached to the left side of the chunk of memory. We can get a memory address from a variable by using the address of operator, which is the ampersand symbol. This operator can be used in two ways. The first is to get the address of a variable. So follow along with me and let's try it out. Here I have the default boilerplate code that we've been using since the very first lesson. So let's enter in int a equals 5, end it with a semicolon. Then we're going to type cout double less than sign a double less than sign int l, and we're going to go ahead and copy paste that line right below it. And now we're going to type an ampersand sign to the left of the variable name. Let's go ahead and save that and run it and see what it outputs. Alright, so here we have the value of 5, which is the variable's value in memory. And then we type the ampersand sign, which says address of this variable. And that address is 009EF980, which is just some random place in memory. Okay, we'll press enter to exit that. And then we'll just repeat it all again for a different variable altogether. We're just going to replace this with B, every place with B. And then we're going to change this int type to a string. And then we're just going to set that value equal to ham sandwich, just to show you that it doesn't matter what variable type is being passed in. All right, go ahead and save it, run it, and we see the output is ham sandwich now, and that the addresses have completely changed now. But notice that they are relatively close to each other, and it's only the last two sets of digits that have actually changed. Very interesting. So the program is working at grabbing stuff sequentially. Okay. We will use this address of operator more as we get into pointers. The second important use of the address of operator, or the ampersand symbol, is to create a reference variable. A reference variable has the exact same memory address and data as another variable. In other words, it is a new variable referencing the same data as another variable. Again, reference the same data. The name makes sense now, doesn't it? So how does this work? We're going to go ahead and delete out most of this code and just leave the a equals 5. All right, and now we're going to type int ampersand symbol, and then we're going to type my underscore ref, because this is my reference, is equal to a, end it with a semicolon. And this ampersand symbol, or the, as we get into pointers, the star symbol, that's going to be right here, can be anywhere in here. Like you can add a space in between these guys. It doesn't have to be next to one or the other. It doesn't really matter. The whole reason that we're actually placing it all the way to the left is because that's a good form to follow. Generally, if you're going to make something a reference or a pointer, you want to put those symbols immediately next to the data type and not next to the variable name. It's just easier to read that way. Below that, we're going to go ahead and type cout, A and L, and then after that, we're just going to repeat it for my ref, and then we're just going to copy paste both of those and pass the ampersand symbol to the left of both of those variable instances in the C outlines below. So what do we expect to get from this? This ampersand symbol, as we stated, was to create a reference variable. This reference variable should be equal in every respect to the original A. Okay, so let's go ahead and run it. And sure enough, that is what is being output. The value of 5 is being grabbed from both memory, and the addresses of both are exactly the same. So what's going on here? Let's go ahead and close out of that. Why is it that we have ampersand, which is the address of operator, only on one side of this equation? Why don't we have it on the right-hand side, like right here, as well? Well, that is because what's going on underneath the hood at compile time, when the program actually compiles down, is every instance of my ref is being replaced with the address of A. In other words, it's saying, replace every instance of me with the data at blank. In this case, A. Cool. Some things to remember about references is references cannot be null, they cannot be changed, and they must be initialized. So we have a way to get the address of a variable. Now, how do we get back from the address to the data stored in memory? This is where pointers come in. All right, so what are pointers? Pointers are really mean-spirited children that want you to cry. They often say something harmful, outstretch their arms, and poop their pants, trying to make you feel terrible, so terrible you cry. I'm not gonna cry anymore. I can do this. Okay, pointers in C++ are a bit hard to explain. Instead of diving right into pointers, I instead want to introduce you to the star symbol, or the dereference operator, which allows us to get the value at an address. Think of the star symbol, or the dereference operator, as a get value at. The ampersand symbol says get address of, and goes left to get the address. The star symbol says get value at and goes right to get the data. How do we use it? There's two ways, just like the address of operator. The first is to place it next to an address to get the value at that address. All right, so back in our program, we're going to go ahead and get rid of everything but that int a equals 5. And then we're just going to type cout a and then int l. Now what I'm going to type in to the left of the a is the address of operator. Okay? So this would output our regular address. Now what happens if I place the star, which we were speaking about earlier, next to it? Now it's going to go backwards. So we have our variable, then it says go left to grab the address, then it says go back right to grab the data. So essentially this is the same as just a regular A. Now if we save it and run it, we'll see we get an output of just 5, just like we'd expect. So we can actually slap on infinite ampersand symbols and stars back and forth to alternate between grabbing the address and then grabbing the data. There's no real point to this, but it's just to illustrate the point that they go back and forth. They are complementary. So again, we have 5 because we entered as many address of operators as we did dereference operators. Cool. So we have a way to get the address and we have a way to get the values back. Awesome. The second way to use the star or dereference operator is to create a pointer variable. A pointer variable is its own block of memory, but the data value inside of it actually just has a memory address. So it has its own address or hoop, and its data is another address, which it is hooking to. This may be difficult to understand, so I want to repeat it. This pointer variable is somewhere in memory where it has its own address. The data that's being stored inside, however, is the address of some other variable or memory block. So it's essentially hooking to or pointing to another variable. Let's see it in action. I'm going to go ahead and copy and paste some code in here because we have so much code to get through, I want to race through it. All right, so here we have up top our variable a we've declared, then we created a pointer variable, and we just put that little star right next to the data type and to the left of the variable. So that's how we create a pointer. In the next line, we actually assign that variable to the address of a by using the address of operator right here. We could actually combine these into a single line like we do with pointer 2, which does the exact same thing. Now we have cout printing out the address of variable a, then pointing out pointer 1, pointer 2, and then we have the address of and dereference operators here next to a, so it will just output a. And finally we have the star next to pointer 1, which should give us the value at that address that pointer 1 is pointing to. So let's go ahead and save it and run it and see it in action. So the first 3 lines are all evaluating to the same thing. The address of variable a right here is equivalent to pointer 1 and pointer 2 right here. The value being stored inside of each of those pointers. Then we have variable a, and it has a address of operator and a dereference operator right there to just give us the value 5. And finally we have the dereference operator next to the pointer to grab the value at that address, which is 5, of course. Cool. So it worked out great. So multiple pointers can point to the same address, which is why I like the hoop and hooks metaphor so much. A hoop can hold many hooks or none at all, meaning an address can have multiple pointers or none at all. A hook can only go into one or no hoops, which means a pointer can point to one address or none at all and be set to null. Final note about plain pointers is they can be null, they can be switched, and they do not necessarily need to be set when initially created. So can you set one pointer equal to another? Think about what happens when you set a variable equal to another. Well, the contents are copied over from one variable to another. So with pointers, it does the same thing. It copies over the memory address stored in one to the other. So they are pointing to the exact same address. Let's see this in action. So here in line 9, I'm just going to replace this %a with P1. That's it. So we're setting P2 equal to P1, and this is going to copy over the contents of pointer 1, which is the address of A, over to P2. And we'll go ahead and run it. And we will see that it does the exact same thing. All the memory locations of A, pointer 1, and pointer 2 are exactly the same still. Cool. Next question is, can we create pointers to other pointers? For the most part, not really. Instead, we can do this with pointer arrays, which I'll show you in just a bit. How do pointers to arrays work? We've actually been using pointers for a while, and we didn't even realize it. Creating a pointer to an array is simply pointing to the first object in the array. So I'm going to go ahead and copy and paste some more code and replace all this, paste, and I'm going to go ahead and drag down the output box down low. What we have up top is variable a, which is an array with values 1, 2, and 3 inside. Then we have pointer 1 that's set equal to the first address of the array. Then we output the value at pointer 1. Then we're going to do some other interesting things, and I'm going to run this to show you what's going on. So here we have the output window, and with the pointer 1 star, we're just saying get the value at this address, which is a value of 1. So by setting it equal to the first option, the first item in the array, we're able to quickly grab that item 1. What's interesting about this pointer is we can treat it exactly as we do with arrays. We can pass in square brackets and then the index of the number that we want to grab, and it'll retrieve it exactly the same. So that's why when I was saying we have been using pointers all along, arrays are really just pointers. So we're able to quickly fetch the first, second, and third items in the array. Cool. Then we have a space to break up the code. Then we output the array variable right here, and notice that it outputs an address. Then when we output pointer 1, it has the exact same address. Very interesting. So again, arrays are essentially pointers. Then we do an odd operation of saying pointer 1 plus 1. Now what's going on here is we're going to jump in memory by one location based off the size of the data type this pointer is. So in this case, it's an int, and it'll jump to the next int location, and it outputs this address right here. And be like, okay, is this really grabbing the next address in the array? Indeed, it is. So we go ahead and pass that same pointer in, and then we call it just like an array by passing in an index of 1 to grab the very next item in the list, and then say, hey, instead of feeding us that value, let's get that address. And indeed, it is the exact same address. So there's two ways of doing the exact same operation. If we have a pointer, we can grab the very next address in an array by just using the +1. Very cool and very tricky. It's going to take some time to get used to this kind of weird coding. All right, so then below that, we have variable b created, and we have pointer 2 created, and we're setting it to the address of b. Now, to illustrate the point that you can call any pointer just like an array, I'm passing in item 0 as an index, and look at what it outputs. It outputs 777. So the dereference operator of star and the square brackets by passing in an index of 0 act the exact same with a pointer. Strange but cool. All right, we'll press enter to exit out of that. All right, so we've created arrays of ints. We've created arrays of chars. Can we create an array of pointers? Why, yes, we can. I'm going to go ahead and copy and paste this code over everything else right here. Let's examine what's going on here. So I'm going to go ahead and comment some of this out. I'm going to go ahead and try to run this code real quick. Notice that there are no errors popping up right now, no red underlines. So now if I try to run it, it does pop up with an error saying, hey, there's build errors. What's going on? You might want to investigate this. So we click no to cancel out of that, and that may be the first time I've showed you that screen, but you'll see that pop up whenever you input something that's invalid and it can't compile the code. What the error says down here in the error list, and you can access that in case you've closed it by going to view error list right here. And what it says is, in very fine print, which you may not be able to read, is that uninitialized local variable p3 used. Uninitialized variable used. So in other words, we haven't set this pointer to a default value like we have with p2 and p1. So we'll go ahead and quickly change that. We'll go ahead and copy that line, and we'll just go ahead and paste it in here and adjust the 2s, 2, 3s on both the p and the a, and we're good. And now it'll compile properly. If we run it, and there we go, the output window showed up correctly. Now we'll go ahead and get rid of all of our comments. All right, and let's examine what this code is doing. Let's go ahead and save that and run it. So let's scroll up to the top. First thing we have is we've created 3 variables, A1, A2, A3, and they're set to values of 5, 6, 7, okay? And then we created pointer 1, pointer 2, pointer 3. And notice that when I created these, I've actually been using commas to declare multiple items at a time. This is a really nice cheat that you have available to you, and I've indented them multiple lines just to make it more easily visible. You could easily have them stacked next to each other like this too. Okay, so we declare the type of int star for these pointers, and notice that we've had to include these dereference operators, or these stars, to the left of every one of these variables when declaring them. This is important. We've passed in the A1, A2, A3 variables, and we've passed in the address of operator to grab the addresses. And then finally, we're going to smash them all together in a pointer array. That's why I named it PA. Okay? And then we're going to do some stuff with that pointer array. So let's see what's going on. First, we're going to try to output what that array is. And since an array is really a pointer, it should just output an address, which it does. Then we say with a star operator to dereference it, or get value at, we're going to end up getting the first item of the array, which is still a pointer. So it's going to give us another address. Then when we dereference one more time, and that'll give you the value of P1, which is A1, and that's going to be 5. Cool. So the dereference operators or star operators work just fine. Do the square brackets work as well? They do indeed. So we're able to grab the first item of the array with that. Notice that these two addresses match up. And then we can use a combination of star and the dereference operator to grab that value of 5. Very interesting, but very clunky. I wouldn't recommend ever doing this line right here. Then we have the third way, which is to pass in double instances of the square brackets with 0 inside. Excuse me. I'm a loud sneezer. All right, so if we scroll down, now we're going to see a space that I've included in the middle to break this code up. Now we're going to again output the address of the original pointer array right here. After that, we're going to say, hey, get the first item, and then give us the address of the first item right here. So line 24, we have the first item of the array being grabbed, and then we say, hey, we want to get the address of that item. Then we're going to output the array +1 to grab that address of the operator as well, so that it should output both of them exactly the same, which it does. And this is just to further illustrate the point that you can add numbers to pointers to get further down an array in addresses. It doesn't get you the values, it gets you the address. Okay? And all that works great. So to repeat what we've learned, arrays themselves are just pointers. Pointers must be initialized before being passed into a pointer array. The star works the exact same as square brackets with an index of 0 with both pointers and arrays. Adding ints to an array will give you the address of that many items up or down. Why would you want to create an array of pointers? It seems kind of odd, right? Well, think about this. If you are dealing with an array of doubles, those are big. Those are really massive values in memory. Instead of trying to rearrange them or swap them if you need to, you can actually instead rearrange an array of pointers that are each pointing to the list of doubles. So when you need to output the array themselves in a different order, you don't have to actually move stuff in memory. It's very, very memory efficient to do this. Lastly, pointers and classes, or pointers and functions, we will cover when we get to those appropriate tutorials. But for now, we're done. Thank you so much for watching. Great job keeping up. Definitely take a few minutes to try these coding challenges shown here and the debug challenges linked below in the description. You are a brilliant programmer, and I'm sure you can do it if you set your mind to it. I will be posting the solutions for all of these problems after a group of tutorials, about 3 or 4 more. But I really want you to develop your own skills and solutions. There's often many correct answers. Please leave me a comment below if this helped you at all. And also check out the comments if you're having problems. Lastly, please do me a huge favor and subscribe to my channel. It would really mean a lot to me. Hit that like button to show some love. Thank you so much for your support, and keep the dream alive.